how do you save $58 million building a skyscraper with a single twist? I know, it sounds kind of crazy, but that's exactly what the architects of the Shanghai Tower pulled off. So we're going to break down the incredible engineering that turned a simple corkscrew shape into an absolute masterstroke of both design and finance. Okay, let's start right here. This quote, "This is the whole puzzle we're solving today. That beautiful, elegant twist you see isn't just for looks. No, it's a secret weapon of financial and structural engineering. The big question is, how?" $58 million. Let's just let that number sink in for a second. We're not talking about the price of a fancy lobby. We're talking about how much money they saved. This is the cost of all the steel and concrete they never had to buy, all because of one single brilliant design choice. So where did that unbelievable $58 million payoff actually come from? Well, to really get the solution, you first have to understand the problem. And that problem, it starts when you decide to build something unimaginably tall. First off, you've got to appreciate the sheer scale here. The Shanghai Tower is a true megatall skyscraper. And when you start building this high up, you realize pretty quickly that you're not just fighting gravity anymore. You're up against an invisible enemy that's way, way more powerful. And here's the thing you have to wrap your head around. For a building this tall, the real battle is the battle against the wind. It can be a totally calm down the sidewalk in Shanghai, but you go 600 meters up, and that tower is dealing with hurricane force gusts. For a structure like this, learning to tame the wind is absolutely everything. So if wind is the big bad guy in our story, we need to know how it attacks. See, the real danger isn't just the raw power of the wind pushing on the building. It's a really sneaky phenomenon it creates, something called vortex shedding. So what is this vortex shedding thing? Well, as wind slams into the tower, it doesn't just flow around it nice and smooth. It actually peels off in these alternating swirls, or vortices. So a swirl forms on the right, and it literally pulls the building that way. Then another one forms on the left, and it pulls the building back. This constant push-pull can get a 2,000-foot skyscraper rocking back and forth like a giant, terrifying pendulum. And this shows you exactly why the old-school building shapes are so vulnerable. A standard, flat-sided, bluff shape is the perfect victim for vortex shedding. The wind has no choice but to flow around those hard corners, and that creates these really powerful, predictable vortices. If the rhythm of that rocking matches the building's own natural sway, you have a recipe for absolute disaster. So if a predictable shape is the problem, then the solution has to be, well, you gotta be unpredictable. The engineers needed to find a way to completely break up those vortexes before they could ever get into a dangerous rhythm. Basically, they had to figure out how to confuse the wind. And this is the genius solution. Instead of building a giant wall to fight the wind head-on, they designed a shape that actually works with it. This incredible corkscrew doesn't just block the wind, it elegantly messes with its rhythm, spiraling that force up and harmlessly away. You know, it's pretty much the same idea you see on a car antenna to stop it from whistling, just on a ridiculously massive scale. Let's break down how it works. First, the shape is asymmetrical, so the wind can't get a steady grip. Second, as those vortices even try to form, the constantly changing surface of the building just tears them apart. Third, that completely breaks the dangerous rhythmic push-pull pattern. And finally, the overall force, the wind load, on the entire structure is just dramatically reduced. It's an unbelievably elegant solution to a really complex physics problem. And you know, it's so important to remember that a design like this would have been basically impossible just a few decades ago. It took some serious advances in computer modeling and material science to calculate all these effects and then figure out how to actually build such a complex, twisting tower. After running thousands and thousands of computer simulations, testing every possible angle, the engineers found the magic number, 120 degrees. That was it. Any more or any less, and the effect just wasn't as strong. It had to be a super precise 120-degree rotation from the bottom all the way to the top. Okay, so we've got the problem, vortex shedding. We've got the elegant solution, a 120-degree twist. So now we get to the payoff. This is where that brilliant engineering turns into cold, hard cash through what I like to call the genius of subtraction. This right here is the direct result of that twist. It slashed the total wind load on the building's frame by an incredible 24%. Think about that. Almost a quarter of the force on the building. Just gone. Wiped out by the shape alone. And this is where the savings really kick in.
The logic is so beautifully simple. If your building has to fight 24% less wind, you need 24% less muscle to hold it up.
And that muscle, of course, is steel and concrete. By cutting down that wind load, the engineers could design a much lighter frame with way less structural steel and a leaner core that needed less concrete. The whole building became more efficient, less expensive, and they did it all without giving up a single ounce of safety.
And that brings us right back around full circle to our magic number. The money they saved from not having to buy all that extra steel and concrete added up to an astonishing $58 million. This wasn't just good architecture, this was brilliant business.
And that really is the ultimate lesson here, isn't it? The beauty of the Shanghai Tower isn't just skin deep. Its elegance actually comes from its efficiency. This is what happens when form and function aren't just in balance, but they become the exact same thing, solving a massive physics problem and saving a fortune all at once. So I'll just leave you with this final thought. The story of the Shanghai Tower kind of challenges us to rethink what great design really means. Was the genius in adding that incredible twist? Or was it in the 24% of force and the $58 million worth of material they were able to take away? Something to think about.